Hello, sir.
Yes, I am audible.
Yeah, you are audible to me.
Yes, Rasul ji.
Hello, am I audible to you, sir?
Yes, audible.
Okay.
Yes, let me start. Briefly introduce yourself.
Okay. So myself Rashid Ahmed, and I belongs to Saharanpur, UP, and I completed my class 12 or class 10 from there. In class 10, I have got 65% marks, and in class 12, I have got 85% marks. After that, I completed my graduation from Delhi University with 67% marks in BSc Honors Chemistry. Then I completed my master's from Jamia Millia Islamia with 80% marks in chemistry. And then I started working as a chemistry teacher in Vidya Mandir classes in 2018 to 19. And then I left the job. I started doing B.Ed in 2019, and I have just completed the B.Ed in 2021. Then I started working again as a chemistry teacher in REG-ID, Haryana. And afterwards, currently I am working here is in Haryana.
Yes.
My hobby is playing cricket, and I find myself like as a teacher because it's my passion to teach students.
Yes, good. Why will you become a KVS PGT teacher?
Actually, in KVS there is a diversity among the students. I have to work as a chemistry as a teacher in KVS, so I have to face all the kinds of culture in KVS. So I want to learn something from the different environments or the different types of culture, and I want to enjoy them. That's why culture. That's why KVS is one of the job for me, and it's also a prestigious institute among the government school currently in India. Right now, currently I'm working here in uh, Rewadi as a chemistry teacher in private school. So I find that the pay scale is also more in KVS, and the standard, or I can say the aura is KVS is more attracting me towards itself.
Yes, good. Your name is Rashid Ahmed. Yes.
Yes, sir.
What do you mean about Rashid?
Rashid is the meaning of the Rashid is the succeeder for a good way, which is like resemble with my profession also.
Yes, good. Are you from UP? Yes.
Yes.
How do you feel about UP?
Uh, what I feel about UP?
Yes.
Yeah, actually, UP is a very like diverse state in India because there are lots of culture in UP, and as we see in different areas among the successful peoples, there are lots of person from which belongs to UP, like cricketers and among IAS officers, etc. So this is what you makes UP like this is way like make the UP. Um, I can't say like different or in like industries or other areas also.
Yes. Who is the education minister in UP?
Right now, actually, sir, I don't know about the education minister. I'll learn about it.
Yes. And central education minister?
Shri Dharminder Pradhan ji.
KVS.
Yes, sir.
How do you feel about KVS?
As far as I know about the KVS, it is the institute for the employees who's working for the central government, because they located all over the India for their job purpose. So in KVS, the subject and curriculum is same for all the students across the India. So KVS is providing basically the equal, or I can say the same curriculum or same syllabus throughout the India for the students.
What is the difference between KVS and NBS?
NVS. In Navodaya Vidyalaya Sangathan, it's like a boarding school, and in KVS, it's not like boarding school. Although the culture or the syllabus is same.
Yes, you have to more study about NBS and KVS. Yes,
Okay, sir.
then will be discussed. Your hobby is cricket. Yes.
Yes, sir.
What is the difference between test match, ODI and IPL?
The difference between test match, ODI, and IPL is in IPL it's of 20 over cricket, and in ODI it's of 50 over match, and in test match it it's gone up to 5 days.
Yes. Yes, good. Next, what is the difference nowadays? You are teaching in Rewari, Haryana. Yes.
Yes.
What is the difference between UP education system and Haryana education system? How do you feel?
Yeah, what I feel is in Haryana the implication of the education policies is more transparent, or in case of UP nowadays also there are lots of work that the government should need to do to implement all these education policies in the grassroots level in the schools.
Yes. Do you know about a National Education Policy 2020? What is
Yes,
the
sir.
advantage?
Sorry.
What is the advantage of National Education Policy 2020?
Okay. Sir, in national education policy, uh, it's the major advancement in the educations of India. According to NEP, the main features of NEP is they are completely changing the subject that the students can opt. Earlier is what uh, felt that a student who belongs to science stream like physics, chemistry, or mathematics, they do not generally study the general subject like geography, history, etc. But nowadays they can opt different uh, subjects or from the other areas also. So this is one of the major part of the national education policy.
Any disadvantage of National Education Policy?
Uh, Sir, there is no, I think, disadvantage according to me, because earlier education policy they are revised, and when the national education policy will be implicated completely, then we can see the disadvantage or anything else.
Okay, good. Any disadvantage of KVS education system?
Sir, in KVS also, uh, I don't think any disadvantage of education system. But what I think is in KVS, it is a prestigious institute. The education system is very good. So a normal person cannot study there. So this can be the disadvantage. A normal student cannot take the admission like easily because it's basically for the central government employees.
ओके, डिसएडवांटेज है, आपने थोड़ा स्टडी नहीं किया, आप थोड़ा स्टडी कीजिए इन पे, थोड़ा वर्क
Okay,
कीजिए, क्योंकि
okay,
केवीएस में डिसएडवांटेज का मतलब ये है, केवीएस का एक तो इंग्लिश मीडियम है, साउथ
okay,
में और नॉर्थ में डिफरेंस आता है, उनकी लैंग्वेज में काफी डिफरेंस आता है, लोग जो वर्क कर रहे हैं उनकी लैंग्वेज में डिफरेंस आता है, टीच करने में प्रॉब्लम्स आती है, बहुत सारी है, आप थोड़ा स्टडी कीजिए तो आपको
okay,
आइडिया
okay,
होगा,
okay.
ठीक है ना?
ठीक है सर, ठीक है, चलो.
यस, गुड. Let's move on. Your mock topic is chemistry. Yes.
Yes, sir.
Pollution, reaction mechanism, and chemical bonding. Three topics. Yes.
Yes, sir.
So
So,
first of
सर ये जो टॉपिक्स हैं केमिकल बॉन्डिंग सॉल्यूशन एंड ये ठीक है मतलब या और कोई चूज कर
yes,
सकता हूँ?
बढ़िया है. बस आपका कमांड होना चाहिए, आप अच्छी तरह से एक्सप्लेन करने चाहिए, जो आप
ठीक
सामने
है,
वाले को सेटिस्फाइड कर सकें बेसिक से.
ठीक है सर, ठीक है, ठीक है.
बस ये टॉपिक आपकी बढ़िया है, आपने लास्ट टाइम अच्छी तरह से बेसिक से किया था. आपके पास व्हाइट बोर्ड है?
सर मेरे पास ना वो पेन टैब तो है, व्हाइट बोर्ड तो नहीं है बस.
तो आप थोड़ा अभी यूज करेंगे?
हाँ हाँ बिल्कुल, मैं स्क्रीन शेयर कर देता हूँ.
यस, शेयर स्क्रीन. यस, कर दिया है मैंने.
इज इट विजिबल? अभी विजिबल है सर स्क्रीन?
यस, विजिबल आ गई है.
ठीक है, ठीक है.
यस, अब स्टार्ट कीजिए. लेट बी स्टार्ट. फर्स्ट बेसिक इज रिएक्शन मैकेनिज्म.
ओके ओके
व्हाट इज रिएक्शन मैकेनिज्म?
सर. सो जस्ट एक मिनट से. ओके सर.
यस.
सो reaction mechanism is basically the reaction mechanism basically discuss about the formation of product from the reaction from the reactants, like we are having the reactant and it's converting into the product. So during the formation of product from the reactant there are lots of steps, and in these steps some intermediates are also formed. So basically, what is reaction mechanism? Reaction mechanism discuss about the formation of product and the process through which a reactant get changes into the product. And in this change, there are some types of reaction intermediates. The first one is transition state, and the second one is reaction intermediates. So reaction intermediates are of different types, like carbocation, carbon ion, free radicals, free radicals. Then we are having carbene, nitrene, and benzene. So these are some important intermediates which are in our syllabus in organic chemistry. And this is the highly unstable state during the formation of product from the reactant, and it is called transition state. So in the reaction mechanism, it is a theoretical aspect of the process how the reactant gets changed into the product. So when we do some experiment in the laboratory, what we find, a reactant gets changed into the product, then we choose a mechanism which suits the formation of reactant to product, and this is what we call reaction mechanism. And during the reaction mechanism, we study some different type of chemical reactions according to their mechanism. So first one is addition reactions. Addition reactions are of different types. The first one is electrophilic addition reaction, and the second one is nucleophilic addition reaction. So in case of reactant which is changes into product, like we are having R is a reactant and S is a substrate, it is changes into the product. These are the intermediates that I have earlier discussed. And now in this case, R, the reagent could be alkene, alkyne, in case of alkyl halide, aryl halide, alcohol, aldehyde, ketone, carboxylic acid. So these are basically the chapter of organic chemistry in NCERT. So these can be the reagent and S can be the substrate. Substrate could be like acid, NaCl, NaOH, like we are having H2SO4, etc. So these are our substrate and these can be reagent. These two combines to form the product. So reactions are of different types. The first one is addition reaction. In addition reaction, it is of two types, electrophilic addition reaction, nucleophilic addition reaction. Now, the second type of reaction is substitution reaction. Substitution reaction. It is of different type. The first one is SN1 reaction. Second one is SN2 reaction. Here SN1 means nucleophilic substitution unimolecular reaction, and SN2 means nucleophilic substitution bimolecular reaction. And the third one is SNI reaction. It is nucleophilic substitution intramolecular reaction. Next is SNNGP, where nucleophilic substitution reaction via the participation of neighboring group. So these are some important type of nucleophilic substitution reaction. Another one is elimination reactions. Elimination reactions. The first one is even reaction, elimination unimolecular reaction, and the second one is elimination bimolecular reaction, and the third one is elimination intramolecular reaction, and the fourth one is elimination reaction when conjugate base is present, and the fourth reaction is rearrangement reaction. rearrangement reactions. Like we take the example of Claisen rearrangement and pinacolone rearrangement, etc. So these are the examples of addition, substitution, elimination, and rearrangement reaction. So in today's class, we are going to discuss some important aspects of substitution reactions. Substitution reactions. In substitution reactions, what happens is a reagent, like we are having the example of Rx, it react. This is the reagent, or we can say substrate. This substrate can be reacted by a reagent like nucleophile, and after the attack of this nucleophile, a product is formed like RNU, and a leaving group is removed. So the formation of product RNU from reactant to product is proceed different pathways. The first one is SN1 and the second one is SN2, third one is SNI and SNNGP. So these are some basic particles. The first one is our substrate. Substrate can be alkyl halide, and this one is what our nucleophile. So there are two type of reacting species. The first one is nucleophile and the second one is electrophile. Nucleophile is electron loving species, and electrophile are nucleophiles are nucleus loving species, and electrophiles are electron loving species, because they are having positive charge and attracted towards the negative charge. They are having the negative charge and they will be attracted towards the positive charge. So what are the nucleophiles? Nucleophiles are basically nucleus loving species. So what are the main conditions to be a nucleophile? The first condition is negatively charged species, negatively charged species like OH negative, CN negative, etc. The second condition is the species having lone pair. They can also behave as a nucleophile like H2O, ROH, etc. And the third condition could be some resonating structure in which negative charge is developed, like we take the example of RCO negative OH. So it is one of the species in which this part can be attacked as a nucleophile. So these can be some kind of nucleophiles, and other species is electrophile. They are electron loving species. They can be positively charged species, positively charged species, like we can take the example of NO2 plus, R plus, etc. The one important thing is NH4 plus cannot behave as electrophile or electrophile, because it cannot further form more bonds. Here nitrogen is already having 4 hydrogen attached with it. Another example is Lewis acids. like we are having FeCl3, AlCl3, BF3, etc. So these are what? Electrophiles. And the third example could be the resonating structure in which positive charge is developed. So that part can also behave as a electrophile. Like in this process, here positive charge will develop and this can behave as a electrophile. So these are the basic attacking particles, nucleophile and electrophile. Now we can take the another part, that is our X negative. It is leaving group. So weak bases are good leaving group. Weak bases are good leaving group. Another important part of this reaction is solvent. Now we need to study about this solvent. Solvent can be of two types. Solvent can be of two types. The first one is polar aprotic solvent and the second one is non-polar solvent. And polar solvent can be of two types, polar aprotic solvent and polar protic solvent. The first one is non-polar solvent and the second one is polar solvent. They are of two types. First one is polar protic solvent and the second one is polar aprotic solvent. So in case of substitution reaction, solvents play a major role. Like if we take the example of non-polar solvents, they can be CCl4, CS2, carbon disulfide, benzene, etc. So these are what? Non-polar solvent. If we take the example of polar aprotic solvent, so it can be DMF, dimethyl formamide. Another example is acetone, etc. So these are what? Polar aprotic solvent. If we take the example of acetone or DMF, so its structure would be like this. Here, oxygen is not having directly attached hydrogen. So these hydrogen are not acidic in nature. So that is why this solvent is called polar aprotic solvent. Here proton or the hydrogen which is directly attached to the more electronegative element is not available. In case of polar protic solvent, we are having the example of H2O, ROH, etc. Here hydrogen is directly attached with the more electronegative element like in water and alcohol. So if we take the example of hydration, what happens? In case of hydration, like we take the example of H2O, if electrophile or we can say E plus is present in the solution and here we are having Nu negative in the solution. So polar protic solvent will solvate E positive as well as nucleophile also. So in case of polar protic solvent, the hydration of electrophile and hydration of nucleophile will take place. But if we take the example of polar aprotic solvent, in polar aprotic solvent, it is of like this. So in case of polar aprotic solvent, electrophile only solvate while nucleophile will be present in the solution. So the solvation of nucleophile will not take place because of the presence bulkier group in the solvent itself. So nucleophile will be free and electrophile will be solvated in the solution. So what we take from what is the conclusion from this discussion of the solvent? Polar protic solvent can be used in SN1 reaction. We'll discuss this in later. And polar aprotic solvent can be used in SN2 reactions. Now we'll discuss something about these two reactions. The first one is SN2 reactions. SN2 reactions are those in which Rx will react with nucleophile in case of polar aprotic solvent. Why we are not using here the non-polar solvent? Because if we take the example of non-polar solvent, then this alkyl halide will not completely dissolve in non-polar solvent because it is a polar molecule. So we need to take the polar solvent. So that's why we are taking here the polar aprotic solvent. So in case of SN2 reaction, polar aprotic solvent is present, and this nucleophile will attack in sigma star antibonding molecular orbital of carbon. Then the partial double bond formation take place between Nu and R, and this bond between R and X will start breaking. This is highly unstable state and it is called transition state. Now if we take the example of some methyl group like this, so we can arrange this group here like this. Okay, so this is what the highly unstable state, or we can say transition state. By the formation of transition state, ultimately we'll get the product like this. So this will be our final product and this will be our leaving group. So what we see here is, if the configuration of this substrate is R, then in this product the configuration will be changed into S. What is R and S? R and S are the absolute configuration of the molecules. Like, okay, so this is called the inversion of configuration. If the inversion is R, and then it will become S. If the configuration is S, then it will become R. So this is called inversion of configuration, or sometimes we call it Walden inversion. Walden inversion. It is completely like an umbrella. Like we are having the umbrella, and when the heavy stroke of air come from this side, then it will invert like this. So in this type we can explain this inversion of configuration. Here we are having these groups in this side. When nucleophile attack from the behind, then these groups move towards this side and the ultimate product is of this. In this particular reaction, what we are observing is the kinetics of this reaction is rate of this reaction will be is equals to concentration of nucleophile and concentration of substrate. So the order of this reaction will be 2 with respect to nucleophile 1 and with respect to substrate is 1. So it is second order reaction, and in this particular reaction, the graph, if we plot the graph between energy and reaction coordinate, so it will be something like this. Here we are having the transition state. It is highly unstable state. This is the energy of reactant ER, and this is the energy of product EP, and the difference between the energy of reactant and product is the EA, activation energy for the forward reaction, and if we take the example, this one is the activation energy for backward reaction. Right. So this is the single step reaction where the peak representing the transition state for this particular reaction. Now, if we take the example of now we need to discuss something about the Rx. What should be our Rx in SN2 reaction? In SN2 reaction, we are observing here the transition state in which, like, this transition state is of sp3d type structure. So if the bulky groups are present here, like H, 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 if the bulky groups are present, then the attack of nucleophile will be slower down. So in case of SN2 reaction, the Rx should be 1 degree and then 2 degree. In case of third degree, rarely SN2 reaction is observed, but it is observed mainly in 1 degree and 2 degree Rx. In case of nucleophile, because it is present in the rate law, so nucleophile should be strong, and strong nucleophile are those which are having negatively charged present on them. Negatively charged species are generally strong nucleophile, like OH negative, CN negative, etc. So these are what strong nucleophiles. Solvents we have already discussed. Now we take the example some good leaving groups. If we take the example of leaving groups, we are having RCl, RBr, RI, and RF. So if the Cl is leaving group, then Cl negative will present. Br is leaving group, Br negative is present. I negative is leaving group, then I negative, and then F negative. So the order of basicity is what? If we take the example of acidic strength, so Hi is the strongest acid, and I negative would be the weakest base. I negative, then Br negative, then Cl negative, and then F negative. So this will be the order of leaving group ability. Now we can discuss something more about the nucleophilicity and basicity. What is the basic difference between nucleophilicity and basicity? So this is very confusing terms. Both are the same, but there is a basic difference between nucleophilicity and basicity. If we take the example of nucleophilicity, it is kinetic phenomena. First thing is kinetic phenomena, and basicity is thermodynamic phenomena. Thermodynamic phenomena. Like if we are having the example of OH negative ion, when this OH negative ion is attacking on R, or we can say the alkyl halide, then it is forming ROH and X negative. Here in this reaction, it is behaving like a nucleophile. But in other cases, like we take the example of C triple bond C H, and we are having NH2 negative group. When this group abstract hydrogen or proton from this species, then here it is behaving like a base. So what is the base? It abstracts proton from the substance, and what is nucleophile? It attacks on the reagent to form the product. So this is the basic difference between the base and nucleophile.
Yes, good.
We'll discuss. Okay.
Yes, good. आपने अच्छा एक्सप्लेन किया बेसिक, क्योंकि इसका टाइम 40 मिनट का ही रहता है। तो
Okay,
क्या
okay.
रिएक्शन मैकेनिज्म आपने अच्छा किया है, क्योंकि मुझे एक आइडिया लेना था कि आप किस तरह से एक्सप्लेन कर रहे हैं। ठीक है,
Okay.
आपका एक्सप्लेनेशन सही है, बढ़िया है, क्योंकि आप ऑलरेडी टीचिंग कर रहे हैं इतने टाइम से। यस, फिर हम नेक्स्ट डे डिस्कस करेंगे केमिकल बॉन्डिंग। यस,
ओके सर, वो ठीक है। आप इसके लिए मेरे को थोड़ा सा आइडिया दे दीजिए कि मतलब जो जनरल टॉपिक्स हैं उसमें मैं कौन कौन सी चीजें पढ़ सकता हूँ, कहाँ से क्या डिस्कस करूँ, मैं उनको स्टडी कर लूंगा फिर कल तक।
केमिकल बॉन्डिंग आप बेसिक कोई सी भी बुक से पढ़ सकते हैं। आपके पास
नहीं
कौन
नहीं
सी?
सर, केमिस्ट्री वाला पार्ट तो मैं कर लूंगा, मैं जनरल टॉपिक्स की बात कर रहा हूँ जो
अच्छा
आप
अच्छा,
पूछ रहे थे ना।